the ones with the 0 in the first spot on the y-axis? James.
Because there's nothing in the x spot.
Yeah, so he said the x spot is your first, the y is your second. This controls your horizontal movement. And when that's 0, there is no horizontal movement, which means you are never moving away from that y-axis. You might be moving side to side, but you're you're not moving side to side. You're only moving up or down, which is why it's on the y, okay? So now listen to this. If the y is 0, then you don't have a vertical movement, right? You're never moving up or down. You're only moving this way. So listen to what I'm about to say, because it is the basis for today's lesson. If it's on the x-axis, the y is 0. And if it's on the y-axis, then x is 0. It seems backwards, but do you understand why, the reason behind it, okay? So here's the lesson that we're going to start. We're using this today. So when we talk about Unit 4, ready? Unit 4 says graph. Graph this way, graph that way, and then graph this way. It's all graphing. It's all about getting a line on the graph. I taught you how to make a table of values to graph. I taught you a couple different other ways to graph. Today we're going to graph using something called intercepts. Yep. This is so nice. Graphing using intercepts is really easy, okay? Hello? Yes, I will. No problem. Bye. Dahlia, go ahead. And then just check on Schoology for the notes, please. Okay? So this is standard 7. Okay? Everybody's standard 7, by the way. So we're graphing using intercepts. I am not making a table of values. I'm not plugging a bunch of stuff in. I'm just finding 2 points that are the intercepts. Intercepts are where the lines cross the axes at. That's the definition of an intercept, right? So it's where the line that you graph crosses the axis. So if it crosses the y-axis, it's called the y-intercept, right? Okay, bye, sweetie. If it crosses the x-axis, it's called the x-intercept. So if I gave you 2 points to graph right here, that would be called the x-intercept, and that point would be called the y-intercept. And that is as simple as it gets, right? That's, well, for right now, okay? So if I were to literally say to you, hey, I got a line. The line has an x-intercept of 2. It has a y-intercept of -5. Could you graph that for me, please? Yeah, that's really as simple as this gets right now, okay? So you're going to say, oh, so if the x-intercept, actually before we even do that, let's do this. Something that's important is that you're going to need to be able to write your intercepts as ordered pairs. So somewhere in caps, do this. Write as ordered pairs. Okay? Meaning a parenthesis with a comma in between it. And the x and the x and the y and the y. So the first part of this lesson is you need to be able to know what to do with that 2. Is that 2, 0 or 0, 2? Don't overthink it. If it's telling you this is the x, then go to the x, which is the first spot, and put 2. And then a couple minutes ago, you just told me that if it's on the x-axis, y is 0. So put a y in the other spot. And then we do the same thing for this. Go to the y spot, put that it touches the y-axis at -5 when x is 0. Are you with me? And then we plot. So I go to 0, -5, I go to 2, 0, and I just plotted or graphed this line that would be normally a pain in the butt with a table of values, right? Let me make sure you understand something. Table of values works every time, but it's not fun. Like, I'm teaching you shortcuts now. That is your fallback. That is your, oh shoot, I forgot how to do it this way. Let me make a table of values. It works every time. But you don't want to do that every time, right? Okay, so now if we get a little bit more, because that was easy. I'm not going to give you a whole test of just like problems like that, right? To move on to the next stage of this, I need to remind you about the difference between slope-intercept form and something called standard form, right? So, slope-intercept form should be something that you're pretty familiar with. You learned it last year. Does anybody remember it? Y equals... No, that's the rate of change. That's good. Well, guess what? That's not completely useless. Delta y over delta x is how you find the slope. Y equals mx plus b, okay? And I'm going to have you just kind of darken in this x and this y. Because when you write an equation in slope-intercept form, that x and that y usually stay, unless it's like a special case. It's the other stuff that changes, the rate of change. The y-intercept, this is called, right? Y equals, negative 3x minus 2. Those are slope-intercept form. You should be pretty comfortable with that. Slope-intercept form means y is all alone. Okay? So standard form looks a little different. Standard form looks like this. ax plus by equals c. And this is your introduction to standard form. You still have your x and your y that don't change. Your a is basically just another way of saying the coefficient for x. The b is the coefficient for y. And c is your constant. So for example, an equation that looks like this is an equation in standard form. Now, the test we just took, do you think you could take an equation in standard form and turn it into looking like this? Yes, you just did that, didn't you? Do you remember doing that? You solved it for y. You subtracted 2x, you divided by 3. Boom. We're not getting into that yet. So what I want you to know is that we're going to talk about graphing equations in standard form now. So are you ready? I know. It's actually, you're going to look at me and go, that's it? Seriously? So here is one equation. 2x plus 7y equals 28. Graph it. So time out for a second. If right now, if I asked you to graph it before I'm about to show you a quicker way, you would probably solve it for y, make a table of values, have to deal with this disgusting fraction of 2 over 7, and it would be horrible, right? Watch this. Okay. I'm going to go back to something that you told me. You told me a minute ago that if it's the x-intercept, that your y is 0, right? Then you told me that if it was your y-intercept, that your x was 0. So guess what? I taught you how to solve and substitute equations. We're doing more of that right now. Let's take this equation and let's make y equal to 0. Okay, so I'm going to put a 0 right there. I'm going to multiply it by 7 and watch what I get. I get 2x plus 7 times y, and y is 0. And you're going to be like, do we really have to do this? This is such a pain in the butt. What's 7 times 0? 0. And what's 2x plus 0? And so finally, after going through a bunch of hoops, right? Jumping through hoops means it's really unnecessary. I'm going to show you why it's unnecessary. Because when I look up here and I see that I'm going to multiply that, I know it's going to be 0. So could I kind of just do one of these and say make x 0? Okay, or make y 0. There I did. Does anybody see what's left? A little itty bitty equation called 2x equals 28. And now I solve. Yes, my x-intercept is 14. But I'm not done because I want you to write it as an ordered pair. What is your x-intercept? Put 14 in the x spot, and that's what you get when y is 0. And then I do it again, except guess what? This time, you get to skip those two. This step is non-negotiable. I need you to write that equation. Okay, so look what I'm going to do now. I'm going to make x 0 Meaning what's 2 times x? 0. I'm going to cover it up. What equation do you see now? I'm going right to 7y equals 28. And I'm dividing by 7. And I'm getting a y-intercept of 4. Which then I put in the y spot. And I make x 0. And I'm almost done. Because the whole point of this is graph it, right? Here's my little graph. And by the way, I'm not even giving you graph paper for this. Because you don't even need any of these lines today, do you? Every point you plot today will be on an axis. So I go all the way out to 14, 0. I go over here to 0, 4. That's all I need. I don't need a table. I don't need a fancy graph. I just need 2 points, and I got them. Yes, Daniel.
I just wanted to make sure, on the top where what is x equals, what is y?
X where?
Right where y.
X is 14 and y is 4.
I mean where y, on top of where y equals.
Okay, can I get that after? I'm going to get you after, okay? Let me just get through this next example, okay? All right, so if I have a problem that looks like that, you're probably thinking, is it always going to be that easy? Is it always going to be that easy? No. What happens if we have a problem that says 2x minus 4y equals 10, okay? And I know this isn't like horrible or anything, but why are you thinking that this might be a little bit more difficult? Because when I go to divide by -4, it doesn't go evenly into 10. Big deal. We're advanced algebra kids. We have a mixed number. So I'm going to let you use the shortcut for this. But watch how what I'm going to want from your work. I'm not going to make you write every single time that when x is 0, y is this. You don't need to write that every time. Okay? All you need to do is this. Cover that up. What is one equation that you see? -4y equals 10. Cover y up. Make it equal to 0. 2x equals 10. I set them both up before I even solve them. And then I just do quick solve, ordered pairs, graph. Divide by -4. Y can equal negative, or yeah, where are we at? Yeah, divide by -4. Y could equal -2.5. It could equal -2.5. You could even keep it as -5/4 if that's how you 5/2, sorry, if that's how you feel like graphing it. 5/2's probably not the best way to graph it. I would probably want it to be one of these two. Divide by 2, divide by 2. Your x is, gosh, I can't think today, 5, which means when x is 5, your y is 0. Your x is 0 when this is -2.5. And all I have to do is plot them. Okay, and I have one more example, and then we're done. And then I'll get your question, Daniel, okay? So go to -2.5. Let me just show you something. When you're graphing like halves, I don't care how specific you get. As long as it's in between the right two integers, you're fine with me. Okay, I mean, obviously, if it's 7/8, then you might want to go closer, but that's fine. 0, guess what? I'm talking too much, and that does not belong there. Why does that not belong there? Where does that belong? This is my y-intercept.
I did that too.
Yes, you guys did too. So I don't move left or right. It's the troubles of talking and writing at the same time. And this is 5, 0. I have my 2 points. I connect them, and I just graphed the equation 2x minus 4y equals 10. And that's it, graphed with intercept. Let me show you one more example, okay? So that's if they're in standard form. Graphing in standard form is pretty simple with intercepts. What if I gave you an equation like this and asked you to find the intercepts? Question, Savannah?
Why is it like a line with the arrows at both ends?
Because there's no domain restriction. Her question was, why is there arrows on both ends? Because we're not restricting the domain, which is usually 90% of the time. There's one lesson we just did, and then that's when there's a domain restriction. But most of the time, it's arrows. Keep going. All right. I know what you're thinking. You're looking at this, and you might be going, oh, I really just want to make a quick table of values and just say 1 and 2, and that's going to be this, and plot those 2 points. No. You have got to learn how to solve using intercepts. Okay? Now watch. If the x-intercept, y is 0, And if it's the y-intercept, x is 0. Make x 0, and what do you see?
Y is -9.
Yeah, there's not even like an equation to solve. When I make x equal to 0, my y-intercept is literally that number. Every single time. When it's in slope-intercept form and y is by itself, this number at the end, 100% of your time, will be where your line crosses the y-axis. I promise you that, okay? And I don't need to do any fancy math to figure it out. I just look at it. That's when I made x 0. A little different story when I make y 0. I put 0 here, and I have to do what? I have to solve a little two-step equation that will take me 20 seconds. Add 9, 0 plus 9 is 9, solve for x. My x-intercept is 3, which means put a 3 here. That's 0. Are you with me? This is pretty simple. So I go all the way down to 0, -9. I go 3, 0, and I just graphed my equation, y equals 3x minus 9, without having to make a table or anything, okay? If I gave you a graph that said this, and we went backwards, hold on, and I said pull the intercepts off the graph and go backwards instead of here's the intercepts, graph them, could you pull the intercepts off easily enough? Hold on. What is the x-intercept here? The x-intercept is going to be -2, 0, running out of ink. And then my y-intercept would be what?
0.
Yep. 0, 4. Got it? Graphing with intercepts. Yes, Savannah.
It's -9